recording. And also I'm going to share my screen. Shit. I just wanted to see like what and all topics we have covered so far so that I could able to start from others. So how was the CAN and UDS communication? Were all of you are able to understand what she was trying to tell? Or is there any doubts till now? Any of the topics like embedded systems or C language, CAN or UDS? Is there any doubts for anyone? Hello? Yeah, am I audible, right?
Yeah, it's audible.
Yeah. So was there any doubts for anyone? If no doubts, I think then we'll start with Autosar architecture. I consider UDS and CAN is completed fully. So C language is finished and embedded systems also finished and CAN is done. The communication protocols, she might have covered all the basic topics whichever it is needed as of now for us. And UDO is also fine. So the info diagnostic services, she might have told about all the standard services as per the S14229 and how we will be testing, how we will be, simulating all those things with the Canary and all. She might have covered all of that. So now let me cover with the Autosar architecture, which is very important for the software engineers who are there in the automotive particularly. So let me start with Autosar. Does anyone have any idea about Autosar? What is this? What is the date today? 9/7/22. Guys, any idea what is this Autosar? Anyone heard about it? Hey guys, come on, yaar. Why everyone is silent? If any of you is working into the automotive, right? So now this is the one of the trendy topic I can say, and the Autosar. Which is a the name itself it will says that automotive open system architecture. Automotive open system architecture actually. So basically what does this mean is like, so how exactly the software has to be, how the software architecture should be there, system or software I can say. I cannot say system, only software architecture. System architecture in the sense it will go in the different way. So how exactly the software architecture should be there is what the automotive open system architecture, which we call it as usually AutoSAR. So everyone should, even if it is a testing or the development, they should know what is this Autosar actually. So how exactly the software will be aligned. So why what is the need of these autos or and all those things we will be discussing it. And what and all things will be there inside the Autosar. So most probably today we will be looking at only the tools. tomorrow, sorry, only at the theoretical things. Tomorrow we will see the how exactly we will do these configurations as part of the software development in the tools and all. I will be showing it. Fine. So let me open the document. So basically, yeah. So previously, what is the need? What is the need of this automotive software architecture? So as we were discussing earlier, to write one software for one passenger car, it will be around nearly 20 billion lines of code. Okay, so if this 20, yeah, I think I have shown you in one of the class, like the file, the .c file, where it was having almost 40,000 lines of code LOC. So if this kind of files are there, so to maintain the 20 billions of lines of code will become very difficult. Okay, got it, right? So to maintain this thing, we should have one a formal way of architecture. Formal way of architecture should be there. So if everyone, if tomorrow BMW wanted to change their architecture or their software which are there in the BMW car, so again they no need to write, and as of now till 2005 or 2004 somewhere, they were having the cases like if they wanted to change any of the software inside the vehicle, they need to pay a lot of cost. Why? Because they don't know where it has to be changed. Again they need to start one new project or new project team, a project team. So each project team, at least they will take 1.5 to 2 years to develop any of the thing. So these 2 years they need to wait, correct? And also for these 2 years, how many engineers will be working? Again, the same cycle will be there. So system engineers, software engineers, and VNV, validation and verification engineers, everyone has to be there. So for all of them, they need to pay. And also sometimes they also need to change the hardware itself. So the cost rate will be too much high in the early era. So what now? All these guys now, like BMW and all. So other vendors are OEMs we are having, right? BMW, Hyundai, Kia. Hyundai and Kia were there same previously. Now they are they are treating themselves as a separate OEMs. And who else here? So
Tata.
Tata. Tata, I don't think it was a part of the previously, but now I am not sure. Mahindra was there, and Ford, GM, all these guys. Okay, everyone was having the same problem. So if any of the car manufacturer wanted to change any of the software, they need to pay a lot of amount. At the same time, they need to also invest a lot of time for developing the things. Okay, so now what happened? Those all guys, they come up with one particular what I can say, one particular approach, like these guys BMW and Hyundai, this Bosch, Conti, this Daimler, and these guys are the just suppliers, okay, for them. So most of the times OEMs will be interacting with the suppliers for any of the software solutions. So that's the reason even they have included suppliers also into their forum for developing this Autosar. Actually, these all guys combined together. Not only these guys, I think I am not having the other picture where it will be showing all the members. Autosar. So all these guys are the premium. So this premium in the sense these guys have paid amount and they have joined into that particular group. Okay, this Alten and Aptiv, ARM microcontrollers, Capgemini, Cognizant Mobility, Deloitte, Electrobit, ETOS, Great Wall Motors, Green Hills Compilers, HCL, Hella Group. Honda, all these guys paid and they entered into the automotive premium group with the KPIT, Magna, Lusoft, LG, L&T, MathWorks, all these guys, Nissan Motors, Renault Nissan, Panasonic, NXP Semiconductors, Renesas, Siemens also, Tata Elxsi, TCS, Tata Consultancy Services, ST Microelectronics, Tech Mahindra, Thundersoft. All these guys are the part of they paid amount and they joined into this one. Okay, so there are other I don't have that image here. It will show all the members who are there in that particular one. These guys. What is this? This one. You could able to see my screen, right? So you can see like 9 core partners. So the first one. So BMW Group, Bosch, Conti, Daimler, Ford, Toyota, GM, and PSA Group, and Volkswagen. They are the core partner. Okay, whoever proposing anything, they all should come into the same page. Then the same page. Then only they can finalize like if they wanted to include any of the things in the Autosar. So at the end of the day, this apart from that, for again for them, they are having the some 48 premium members and 11 development members. I mean members in the sense they are the companies actually. So you can see like general OEMs in that 48 premium numbers again they have segregated general OEMs, tier 1 company standard software, tools and services who are providing for this particular Autosar and semiconductor companies. Okay, the Honda and Fiat FCA group and Honda Kia Motors, Mazda, Renault, Volvo, all these guys are the part of premium members, but they are into the OEM. So and tier 1 companies now, Delphi now they have shifted that changed into the Volkswagen actually. Delphi and Magna, Lear Corporation, Value, Johnson, Etos, Magneti Marelli, ZF Group. All these guys are into the tier 1 companies. Like they will be having the production also like Bosch. Even though it is Bosch is a production a tier 1 company, but still they are the part of the core partners. Okay, and EBIT resource and Mentor Graphics, Vector, all these guys are the standard software providers for the AutoSAR. And tools is provided by the Altran, DSpace. Altran will not be providing any tools actually, but they are the software providers. Altran, L&T, and Tata Elxsi, Wipro. All these guys are the software providers. KPIT also they are not providing any tools. So KPIT is providing some of the tools called the KSR and all, but that we will be seeing it later. And semiconductor group is like Freescale, ST Microelectronics, Infineon, NXP, Renesas. So we will be talking more about the Infineon controllers why? Because this is one of the trendy semiconductor provider as of now for the automotive as of now. So these all companies will be collaboratively working towards the Autosar development. So if any of the decision if they want to take it, so they will be connecting with all these guys. Even they will include the tier 1 companies. I can say the premium partners. The main motto of this Autosar is like Autosar, as it name suggests itself, like it is an open system architecture. So it is not which the company has to buy. Definitely for the development of Autosar architecture, they need to buy the tools and all. For that they need to pay. But architecture wise, it is open source. Can anyone tell me what is the architecture means? Hello, any
Planning.
idea?
This means planning.
Uh, Planning will not come. Planning at the project level it will come. The architecture in the sense like I think you were telling about the civil architecture concepts wise, but it's not something like that. But architecture even in the civil also architecture in the sense like how are we going to manage the things? How are we maintaining the things? What is the structure of it? Correct. So it will basically says that the structure, how the things we are going to maintain, all those things it will come under the architecture actually. So this architecture, if it is a standard, if it is a standard, then all these companies to change any of the software inside their vehicles, no need to spend that much time, right? So if this architecture is standard, then all the software developers will knows that what is that architecture. They knows that what they have to change exactly. It will be very quick. I can tell you how it will be very quick. If we are not spending that much time, definitely then there will be a chances of very less time to be taken to develop any of the software change in the vehicle. So all these things will come for the OEM with very limited period. If they are combining, if they are collaborating with each other and developing one of the particular open source architecture, so that's the reason they come up with the Autosar. Getting it? So all they together, all the OEM together are the by taking the help from the premium members of Autosar, they have developed the Autosar architecture. Still, it is in the development from 2003. Still, they are in. Still, they all are working towards to develop the better Autosar architecture. So, this concept is keep on going on as the day needs it. Like they are changing the things and all inside the architecture. Again, it is having the different kinds of things and all that I will not be going today, like a classic Autosar and what is that other one? Classic is one and dynamic is the one, I think so. Classic and dynamic Autosar. Dynamic in the sense on the runtime, if EC is running also, then they should be able to change the software or something. Classic is like a static one. It could not be changed. Once you have developed means developed only. Got it? Any doubts?
Yeah, got it. No, no, no.
But Saint and all.
Mm-hmm.
No doubt.
No, someone was asking something. Was there any doubts to anyone?
No.
Fine. So, what these OEM guys were doing, so for example, if the software is architectured very in a proper way, so all the software developers knows that which component or which .c file is where. And what these guys have done is like in the layered architecture, they have maintained it everything. So what will happen, like entire software, they I need to make it big. Let's take if this is one of the software package. Okay, let's just see architecture in the sense I want to say this one. So architecture is like just a, our imagination. Okay, in the similar way, you never see this architecture anywhere, but it should be there in your mind that it is going to build in this way, the software. Okay, the way how the files are going to organize is what the architecture in this case. So the 20 million or 20 billion lines of code, if it is having, we will be splitting that into the different .c and .h files, right? So this different .c and .h files, it might be having the 20,000 files, right? This 20,000 files, how we are going to handle it in the one particular folders and the, the file explorers is what it is showing the architecture. Getting it? So inside Autosar, basically it will be having the three major layers actually. We call this as application layer. And this is a runtime environment. This is runtime environment, and this entire thing we call it as a base software. Base software. Okay. So this is the application, like we are talking about the airbag systems and all, right? Airbag systems or the ADAS ECU, ADAS in the sense advanced driver assistance system applications and all those things. Like it is having the AB, ACC, LKS, all these features we have developed, right? We have discussed, right? All this feature level implementation will be there in the application folder. So if tomorrow wanted to change, like and also this after BSW we will be having the microcontroller layer. Okay, microcontroller layer. This layer I cannot say this is actual hardware, actual hardware, the microcontroller. Getting it? So basically, if tomorrow if we wanted to change, see for example, this ADAS ECU is there. Now in 2022 we have developed it. Okay, in 2025 manufacturing year, I can say in 2025 for manufacturing year 2025, the ECU which we are going to use it now, as of now we have used the Infineon controller, Infineon 32-bit controller. So if this is not sufficient for the year 2025, then we need to change this Infineon controller, right? We can go to either Renesas. These all are the manufacturers. Okay, Renesas are the unlock devices, or the ST microelectronics. So any of the devices, if you are going to change it, that time basically we no need to change the entire software. Okay, application you no need to you no need to touch at all. So that will be the independent. Like if application is going to change, then you no need to change the microcontroller. So in between again we will be having the different layers. Actually we call this as a service layer. I think I have the document. Let me take that. So this is the open source document. Still, I will be providing this document to every one of you. Even if you are searching in the Google, like Autosar architecture, basic software architecture, still you will get this document. Okay. This is open source. Everyone can able to access it. But the tools whichever we are going to use to develop this Autosar architecture based software, the tools will cost a lot. Each tool license will be more than 10 lakhs, something like that. Okay, so in this document majorly these are the content what we are having it, but here what we are going to see majorly is the overview of software layers. We will be seeing it for some of the software layers, the content we will be seeing it. These multi-core systems and mixed critical systems and all we will not be seeing it, and overview of modules we will see it. This configuration part tomorrow most probably I will be taking up with the real-time tool itself. And integration and runtime aspects we will not be seeing it. It's not needed for everyone. Okay. So you can see like this diagram. Okay, further it will be going to um, it will contains all the software components, how it will be coming and all those things. So now this is the high level Autosar architecture what we will be seeing it. Okay, so going further, still we will be deriving this particular document into the bits and pieces. You will be seeing it. Okay, that is what I was telling. This microcontroller. Let me take this diagram. Guys, at first time itself it is not going to understood that much clearly, but if you are seeing this document once or twice, or this video once or twice, you will not get any proper videos anywhere in the YouTube or somewhere else for this particular concepts. Actually, that's the problem. So but still, if you are finding any, now the guys are coming up with the some of the things. Actually, if you are wanted to see really, you can go ahead and see there, but still they are also at the theoretical level only. No one is having the open source tools for it to develop or do something else. So if you are into the project, that into the Autosar project, if you are the developer, then only we could able to explore the things into the Autosar. But if you want to enhance your skills into the automotive with the software development, definitely you should know the Autosar. Okay, so as we were seeing these concepts like sorry, ABR, ACC, all these are the features, right? So they all are the application level. Application in the sense, don't confuse again with your applications like the Chrome or the Microsoft Edge and all this kind of application. The application in the sense, the one which it is going to do the some kind of task in our real-time embedded systems. Okay, so in case of washing machine, what is the application it will have? It will just wash the clothes. In case of ADAS issue, the application is autonomous emergency braking, so automatically it will apply the brake. That is one feature is that we call it as a one application layer, one application software component. Adaptive cruise control, lane keeping assistance, lane keeping departure, lane departure warning, what else, traffic sign recognition. All these are the application features. Okay, all these concepts we will be developing inside the application layer. Okay, runtime environment is like if application wanted to interact with the base software, this base software might be constant. Okay, this base software will be constant. It depends on what is the use cases you are having. So this base software basically it will be provided by the vector, and KPIT is having their own base software. And what else here? There are EBIT resource, electrobit also. Now it is part of the Conti. And who else? That one thing I have seen it. I forgot that company. Mentor Graphics. Mentor Graphics also they will be providing it. Graphics, okay. So this base software, all these guys will be providing. This base software is a constant, okay. There will not be any much changes here. So they will be giving one particular software. That software, however you wanted to use it for your particular issue, you can be using it. So this Autosar architecture, we will be going to implement at the ECU level, not at the vehicle level. Vehicle level Autosar architecture is not there, but it is at the ECU level. If any of the thing within the ECU, if you want to change it, you need to follow the basic Autosar architecture. So depends on that only you will be going to do it. Okay. So if for any of the application, if you see, for example, now I have developed with the Infineon controller. Tomorrow, if I want to add any one of the other features with the same software, again, I need to just change inside the application layer. That's all. Then that feature is going to work out. So in that time, I don't need to spend time to develop the base software, runtime environment, and all. Very minimal effort you need to keep it. Okay, and this standard is this is the this architecture is a standard throughout the organization or the throughout the industry, I can say, or the automotive industry. If tomorrow the one who I have developed is like application feature which is LKA, if tomorrow I am not there in that company or in the team, but still whoever coming as Autosar developer, he knows that what he has to do. There will not be any dependency on the other developer, whoever developed previously. So the someone might have implemented something in the 2019 and he left the company. So now at the same OEM, which is a BMW, is coming back to the Bosch and asking that, guys, can you develop this particular feature for me now for the 2023 manufacturing year? So it's a very minimal effort for the whoever the developer that time. Why? Because he knows what is the base software it will be, how the RT is going to work out. Then for him, it's a matter of just implementing the traffic sign recognition in the application layer. He no need to change the microcontroller. He no need to change the base software. But still, if he wanted to change, there will be very minimal effort here. So it is a standard, I can say, throughout the automotive industry. Even if it is a passenger cars are the heavy trucks and all, halfway road vehicles and all, heavy trucks. And what else, now the even this company LG and all, whoever providing the embedded systems, right, even they are coming into this, they are going to use this automotive open source open system architecture technology actually. So it's a kind of very layered way of architecture. So everyone is, trying to use it for their future purpose, actually. So this is how the it. So for example, if you want to change any of the thing in the base software again, it will be having the different layers that we will be coming in the next picture actually. That we will see it now. So this is the next picture what I can see. So step by step, these guys will be deriving this entire architecture into the full software components. You guys just remember all these things. You will be seeing one final picture where it will be showing all the components and all. Okay. Okay. So we saw it at the high level. So application layer, it is not going to change. RT is not going to change. Only the things will be getting changed from now onwards is in the BSW. Application developer will not be limited by any of the things. So inside application layer, whatever you want to implement, you can implement whatever the features. Runtime environment is just a one handshaking component between the application layer and the BSW layers. So here the BSW is the what we will be looking out. Even though if it is a standard software, this is going to developed by the vector or mentor graphics or whoever it will be. It's they will be developing the stack. This we will be calling as a vector stack or the mentor graphic stack or EB stack or something like that. So why? Because this entire BSW they will be going to give. Even though if they are giving it, the base software only they will be giving it. So we will be using the DaVinci tools to configure this thing. DaVinci tools actually. So these DaVinci tools, there are two tools: DaVinci Developer and DaVinci Configurator. In case of vector, DaVinci Developer and Configurator, we will be having it. So this standard software they will be giving it. This developer and configurator will give you option to configure the thing. So apart from the application, this entire BSW now it will be tool generated one. You will not be doing any of the things here. You will be just doing the configuration whether this option you needed in this software or not. This I will be showing it to you tomorrow. Okay. I will take any one of the communication stack, and then I will show you like what and all configurations it is needed and how it will be going to generate other things. Okay. So this service layers like OS services and all those things it will be having like this. What does that meaning? This particular services the components will be keeping in the one particular place, like to see how exactly to which other software components are the to which other BSW components it is going to interact is what we will be specifying clearly in this particular diagram moving forward. So this is the service layer. This is ECU abstraction, or we call it as a ECAL layer. This is MCAL, microcontroller abstraction layer. This is a complex device drivers. So complex device drivers in the sense like if any of the software components which we cannot keep under the Autosar architecture, like in any one of the service layer or the ECAL or MCAL, then we will keep that as a complex device drivers. Getting it? Let me take the final that final diagram. If I'm taking directly, you guys will get confused. That's the reason I need to go step by step only. The final diagram it will come in this way actually. um, Even if you are not that much proficient in this Autosar, at least you should know the basic things. So that's the reason I'm explaining all these things. So where does that went? Let me take the final diagram itself. So this diagram I wanted. So here the coloring you can see it. Okay. So how exactly they are calling all this ECU abstraction layer and runtime error and runtime environment application layer. Service layers is in the this color. ECU abstraction in green color. Microcontroller, which is MCAL, is in the the other color. Microcontroller is in the black color. All this kind of coloring they are going to use it actually. This is just for the architecture level they will be showing it, but at the real time how the things will be coming out and all those things we will be seeing it now. So inside application we have discussed what and all it will come. RTE is just handshaking between application to the RTE, application to the BSW. So if you want to interact any of the interacting in the sense, if you want to fetch any of the information from BSW to the application or application to the BSW, then definitely it has to come via RTE itself. So even if inside application software component, if you have the software component 1 and the software component 2, if they wanted to interact also, they need to go via RTE only. They cannot directly interact even if they are in the application layer itself. Okay, so the concept of using the global parameters like external variables will not be allowed in the Autosar. If they are the standard application software components, then the global variables, which is called extern and all we have seen in the C language, right? Extern int a. This extern we will not be going to use in case of Autosar software development. So for that only, if you want to interact anything between the two software components, definitely you need to go via RT only. We will be creating ports and all that we will be seeing it tomorrow. Getting it? Let me see if I have anything regarding. So this is the previous software which I was having it. So inside it, these guys are having Autosar configuration. Okay. So inside it, the DaVinci and all they have it. I don't want that. So you can see here, application they have divided. I will show tomorrow the real-time project. Now I doesn't have the access to that PC. So the application layer, in the sense under application layer, whatever the components it will come, all those things they have kept under the SWC and application actually. So CDD is like these complex device drivers. And model-based application software also, it's a part of the application software component. So the how the folders they are maintaining is what the matters actually. MCAL in the sense all the microcontroller related. So inside this MCAL you can see like source file, right? So MCAL init list and all they have kept it like all the initialization things and all those things. Not this one. Auto embedded software, Autosar, integration testing, they have it. MCAL you can see like under the MCAL BSW, whatever for ADC they have one file, for BFX, CAN, CRC check, digital input output. all these six. See here, you can see right under IO, we are having the DIO. For DIO, they are having the folder here. So that is up to them, like how they are going to handle it. But they should know, they should follow all these component names properly. That is the mandatory. The folder structure, however you are maintaining, that's fine for that is up to the project. But all these components should be there, and the interaction should be there as per the Autosar standard. Interactions in the sense, what I can tell is like, if the software component 1 and 2, if they are trying to interact, then they should not use any external variable. Even if they are trying to connect with, or interact with each other, they should do with the RTE itself. And application layer directly, it cannot connect with the microcontroller layer. Application layer, if they want to connect with the microcontroller layer, which is MCAL, this is MCAL, okay. This is MCAL, microcontroller abstraction layer. This is ECAL, we cite ECAL, right? ECU abstraction layer. This is a complex device driver, CDD. This is a service layer. Service layer. Okay. So if application component, if any of the LKS or whatever it will be the future, if they wanted to, transmit any of the message directly, it cannot go microcontroller and it cannot transmit. So that transmission flow, that transmission is having some flow. So it should come to the communication services. From application layer to the communication services, it should come, and via RT only it should come. And inside communication services, the COM is the one which will be taking care about the communication, like CAN message transmission. COM will give that information to the PDR. That's the reason you can see the COM is just lying just above the PDR. So this XF is there, right? It cannot interact directly with the PDR. Okay, PDR cannot directly interact with the application layer. What I can say is like, this is the modules or the components which will be independent of other modules. So application is purely independent of entire BSW. Application is depending on the only RTE files. Service layer is purely independent of the microcontroller abstraction layer. If you want to change anything in the service layer, only RTE may affect and ECAL may affect. If you want to change anything in the ECAL, only ECAL and the service layer and micro memory drivers will be going to affect it. Microcontroller will not be going to affect. If you are going to change the microcontroller, only MCAL will be going to affect, and little bit part of the system services will be going to affect this one. Why? Because with the system services, the OS is going to interact directly with the microcontroller. You can see that is how this my Autosar is layered. So that is what they are saying, that layered software architecture. Getting it? Any doubts? Hello? Any doubts to anyone?
No, no, no. I'm getting
See,
it.
this microcontroller, if you are changing, then there will not be any effect to the software. It will just basically affect the microcontroller layer, that's all. Tomorrow, if BMW wanted to change their microcontroller, still they can go ahead and they can change. They need to put very minimal efforts for the MCAL implementation. MCAL little bit changes only. There also there will not be any major changes. If tomorrow, if you want to add any of the application software on top of the same microcontroller, still you can go ahead and you can do. Entire software will be entire software will be same. Very few minimal changes you will be doing in the application layer. This, if you are doing in the application layer, only RTE is going to affect. Getting it? All other components will be same only. You no need to change operating systems. This OS you no need to change. The same OS can able to handle the one more software component in the application. You no need to change any diagnostic related things. You no need to change how the CAN communication was implemented previously. The entire things will be same, but very few changes will be happening at the in all the layers. Apart from that, all other things will be same. Tomorrow, if you want to change, if you want to remove any of the software component, that also fine. You just go on ahead and you remove this SWC. Still, it will not affect entire ECU development. The same hardware, same software, but still you are going to just delete some of the things which will not affect any of the ECU development. So it's going to save the time. If it is going to save the time, and definitely it is going to save the cost of expenditure for development. Getting it? So this NVM, if we wanted to interact, also it cannot directly. In some cases, it will directly interact with the parallel. Most of the time, it should go to the Autosar runtime environment and then it should come back. This cross communication cannot be happened, is what I'm trying to say. So BSWM cannot directly interact with the memIF. NVM can interact with the memIF directly. At the same time, NVM cannot able to interact with the PHY or the EEPROM. You can see the components here, right? So if this PHY can able to interact directly with the EEP, or it may go to this component also. This is a mem stack, okay. And one more thing. So if you are looking at the horizontal levels, we call it as a service layer, ECAL layer, MCAL layer, and all those things, right? If you are looking at the vertical things, so if I'm seeing this is the communication services, okay. This is a com stack, I can say. Communication stack. So if you are seeing at the memory services, this entire thing, this I call it as a mem stack, memory stack. This I can say IO stack, input output hardware abstractions. This is IO stack. Getting it? And this is OS stack or service stack, we call it as. Vertically, if you are speaking that, we call it as a stack. But again, this stack is the term which we will be using frequently. So from the vector point of view, also this entire BSW, we call it as a stack. Then if it is coming to the individual developer, then again we call it as a com stack, mem stack, system stack, IO stack, and all those things. Getting it? Guys, getting So let me take one of the example, okay. So I wanted to transmit one of the message, okay. Transmit message, which is of type CAN, okay. Okay. CAN message I wanted to transmit from my application layer. Hey, was there anyone was asking any doubt? No, right? Hello? You guys are able to hear me?
Yes, bro.
Yes, sir.
Fine. So what I was telling is, if I wanted to transmit any of the message over the CAN, you guys know, right? What and all the things will happen if you are trying to transmit the CAN message and the UDS message or whatever it will be. All of you are very clear, right? I saw just the high level that videos actually, so it was quite good. Everyone could able to understand it. She was covering all the basic things and all, I think so. So this, whatever the CAN message, if you wanted to transmit, you will be preparing one of the data which you wanted to transmit, right? The data might be 8 bytes, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 1, 2, 3, 4, 5, 6, 7, 7, 7. This is the data which you wanted to transmit on the CAN message, any one of the message. So this data, it will come to the RTE. From RTE, I will be having one interface to the COM. So from COM, I will be having interface to the PDR. PDR will decide that where it should go actually. So whether it may go to the transfer protocol, she might have told this transfer protocol, which is it will be having the single frame or multi-frame. If in case of multi-frame, again like a first frame, consecutive frame and flow control frames and all, she might have told, right? This is a CAN TP. So if it is not, if multi-frame, when it will come more than 8 bytes of data only, right? So, but in our case, it is just 8 bits of data. So then it no need to go to the TP directly from PDR. It will come to the interface module. So here it is mentioning XX. You are able to see this. Yeah, are you all of you are able to see this diagram properly?
Yeah.
Yes, sir.
Yeah. So this XX is there, right? So what does that mean, XX? You know, this we are calling it as a communication stack, right? Com stack. So this communication, in the sense, it may not be necessary that the communication should happen only on the CAN. Okay, it may happen on the LIN. It may happen on the Ethernet. It may happen on the SPI, may happen on the I2C. All these are the communication protocols. Any one of the protocol you can be using it. I have just taken it as a CAN communication protocol, so that's the reason. So in CAN communication protocol, after PDR, it will be deciding that this will be the CAN IF module. Okay, CAN IF. So interface in the sense IF. So if it is a Ethernet or the LIN, then it will come as a LIN interface, LIN IF. LIN IF or Ethernet IF, ETH IF, all these things will be coming. So it will be common. That's the reason he's just mentioning XX. Okay. So from CAN transceivers, I can directly go and I can connect with the CAN driver, which will be there in the CAN driver is just a software component. So whatever we are seeing here, right? Whatever we are seeing here, all the COM, PDR, TP, interface, and the CAN. All these are the software components only. Software, I can say BSW components, base software components or modules. Okay. So how we will be keeping these names to the one of the .c.h files. So this entire the basic software will be given by the vector only. In our case, basically. So depends on the however you wanted to connect between these components. You will be just doing the configurations for all of them, but that is a standard thing. What I'm trying to say is, like, from CAN IF to CAN you can connect, and it's up to you whether you want to go to the transceiver or you can directly come from the CAN IF to the CAN, and PDR to the interface you can come directly, but the COM cannot directly interact with the CAN IF. This is the standard flow which you need to follow. And also, if you want to store any of the information from applications, see, for example, you are driving and whatever the information which you wanted to store into the microcontroller NVM, which is a non-volatile memory, still you will be just asking the memory services, which is NVM. Then NVM will ask memIF. MemIF will have either fee or someone else. If fee is like EEPROM message, actually EEPROM memory. So fee can able to use the FLS drivers. From FLS, you are having the memory in the microcontroller, right? Then it will store into here. This path you cannot avoid it. Are you guys are getting it? Directly from application you cannot store into the microcontroller is what I mean to say. In between, it has to traverse through all these modules. Getting it? If tomorrow, if you want to change any of the thing in the FLS, then only FLS may going to affect. Apart from FLS and the microcontroller, actual hardware is going to affect, and the fee is going to affect. So the above layer and the below layers are the one which will be going to affect. Okay. In case of microcontroller, if you are changing, only MCAL is going to affect. If you are changing something in the ECAL, only the memory drivers and the memory services is going to affect. If you are changing anything in the application layer, only RT is going to affect. The remaining software will be keep on constant or same only. Getting it? So in the similar way, if you want to transfer the same data on the Ethernet, okay, then it will come to COM to PDR, PDR to Ethernet interface to Ethernet driver. If you want to send same data from application layer to COM, it will come. COM doesn't know what kind of protocol it is going to transfer the data, okay. Then PDR will be deciding to where it has to transfer that, whether that is the Ethernet protocol or the CAN protocol or however it will be. Then PDR, from PDR it will come to the LIN interface. From LIN interface to LIN it will go. If it is a SPI, then LIN interface to SPI interface to SPI. So from here again we will be connecting all these things to the pins. So we discussed, right, microcontroller will be having all the pins. nearly it may have the depends on the capability of microcontroller. It will be having around 100 to 150 or something like that. So some of the pins will be supporting for the CAN protocol there. Getting it? Any doubts here? So no one will be very perfect in the entire Autosar. Okay, I don't think at all. No one knows all the modules. Okay, if you are perfect at one particular stack, then you are the master in that particular stack development. No one knows all the components. It will be having around nearly 1,000 software components are the modules. No one knows how exactly they are doing it in the real time systems. Well, guys will be very perfect only at the communication services or the some memory services or the system services or something. Still you cannot able to understand what the interfaces are there. Even though if I'm doing from a very long back, still I'm not sure what kind of interfaces it will come. If I have the any of the doubt, I will go to the Google and I will search like what is this module. For each and every one of this module there will be one document. Okay, so if I say the RTE, if I go RT the Google and says that RT SRS Autosar, it will come out to specification of RT, how exactly the RT is going to work out and all those things it will be coming out. For each and every module there will be document. You can see like what exactly it will be doing RT functional specification. If I'm not sure of any of the component, then I will go this particular documents and then I will be seeing what is the functionality of it. So what and all configuration parameters it will be having and all I will be checking. See, you can see RT ECU configurations, how exactly we need to do the configurations and all. It will be specifying at the requirement level. This is the requirement levels, requirement numbers actually. No one knows what is still today. If I'm getting a doubt in, see, basically I'm not sure about still the system services how they will be interacting. I will be just interacting with the BSWM and COMM. This couple of components only I will be working. Majorly I will be into the communication stack development actually. So that's the reason I will not be bothering about what is high abstraction it will be having. These complex device drivers and also I will not be that much perfect, but I will be implementing the things, and the NVM also I will not be fully configuring, but as part of my development for the communication stack, I will be doing some of the configurations here. COM, BSWM and OS related and ECMs and all DEM and all this we will be looking at very minimal times actually. Every time I will not be looking. So that's the reason I'm telling that no one will be perfect at all the Autosar modules. Okay, if you want to learn any of the Autosar concept, then you can just concentrate on one particular stack. Either it might be mem stack or the communication stack or IO stack or whatever it will be. Getting it? So whatever the component it might be, you can just go to Google and just do the Google. It will give you the document. So it is open source. You can see the Autosar org is the one. The consortium, I can say they will be having all the documents here. So if I go to the Autosar architecture, Autosar organization, so it will be having all the classic adaptive platform. So whatever I was telling now, it is a classic platform. Adaptive is now it is slowly booming it. Till now it is not come that much fast into the industry, but it will be going to rule the entire automotive. This adaptive platform Autosar. Okay. So they will be having all the documents and all here somewhere actually. Here, if you come down, classic platform. So inside it is showing here Visa, Comstack, Memstack, and system services and all right now. Crypto stack also it's coming, and off-board communication services, which is a wireless Wi-Fi communication. Even though Wi-Fi is a communication service, but still they are going to handle in the separate. Still it is in the development. Off-board communication stack. Crypto stack also still it is in the development only. Previously it was part of the system services basically. Now they made it as a separate stack, which is a cyber security stack. Okay. So basically, the guys will be asking which standard, which Autosar release you guys are using it. So it will be basically 4.2, 4.3, 4.33, 3.1, and all those things. So if you see the latest one, 4.4.0, it will be having all the, what I can say, the documents here. You can download all of them. So all the crypto related documents will be here. All the communication documents will be here. If I'm downloading it here, so all the communication related documents will be in this one. Getting it? So if I want to see like a comstack, entire comstack, you will not be getting it. Autosar, if I am searching also, I will get the document specification for the communication. So that com module we saw it, right? So here the com. This com is there, right? This com. So each one of this, it will be having its own documents. Okay, DCM also it will have document. PDR will have its documents. CAN IF will have its documents. CAN it will have document. All the modules will be having its individual documents. So each individual document will be specifying that how exactly we are going to configure. If you are configuring of the parameters, how it will be going to affect on all those things. You should have the very concentration here if you are going to study of these documents, otherwise you will not be going to get any of the things. So basically it will just gives what is the functional specification it is going to do it, functional overview. This if you are studying now, you will not be going to understand it. Basically, yeah, what I meant for this class is like the basics of Autosar I am going to give it. Tomorrow if anyone wanted to learn any of the stack, then they can come back to me with the group so that I can conduct a separate class for them. If I'm going to for the separate class, then it will be now if I'm going to do the individual configurations for each one of these modules, it will take a lot of time for me, which I don't want to spend. If you guys are having the basic idea of this Autosar, if the motto is like you should be able to understand what they are trying to speak if you are joining into the any of the project. You should not be get a surprise that what is this modules, what is this Autosar, what is this RT and all those things. Okay, if anyone wanted to have the deep knowledge about this, or if anyone is going to work on these particular concepts like ComStack, com configurations, or and all those things, they can request me for any of the separate class. So I can conduct one separate class for them to show on the separate configurations how it will be happening. But anyhow, tomorrow I will be going to show for all of you to configure one of the CAN messages. Okay. Any doubts? So let me show you now the com stack itself. The mem stack and all those things I will not be showing it. We'll directly enter into the com stack itself. At the high level, we will just see it. I think you must have got now itself like what is the at high level how it exactly it is going to work out. So that is the things he is explaining in this PPT. Yeah, guys, this is standard documents. That's the reason I have not prepared any of the PPT for this. I assume that this PDF is enough for all of you to understand what is this Autosar. Okay. So at the layers level architecture, he has given the overview like the microcontroller abstraction layer. So what he is trying to say is like it is independent of the other modules. It will be depending only for the ecal if it is going to change any of the things. Similar way for ecal also. Ecal will be directly in some cases as we saw it already in this one. So this IO abstraction, even though we are calling this as ecal, this green color one, still in some cases it is going to interact directly with the RTE. It no need to traverse every time with the service layer. If it is IO hardware abstraction, the signal interfaces and all directly it will go to the RTE, from RTE to the application layer. In some cases, we need to interact directly from microcontroller to the application via RTE. Then in that case, we will go ahead and we will use the CDD, complex device driver, we call it as. Okay, but irrespective of all of them, if you want to do the normal communication via CAN or something, then this is the path which you need to follow. In case of this is in case of reception. In case of transmission, the same path again. This is for the transmission. Getting it? In case of if you want to access any of the memory peripherals which are there in the microcontroller, then this is the path which you need to follow for writing and reading it. If you are writing anything from the application layer to the microcontroller, then this is the from top to bottom you need to come. If you are reading from anything from the microcontroller to the application layer, then you need to come from down to top. You guys are getting? So if you are taking any of the components with what and all it is going to interact and all, also it will be showing in the document actually. I cannot go to the each and every document to explain all of these things. Everyone has to read there individually. Then only will be going to understand the things. And definitely read it. If you are getting any of the doubts, just come back to me. I will help you to understand a little bit more. Okay, that is the things he has given here. The complex device drivers, if they wanted to interact from microcontroller to the application via RTE, directly they can able to interact it. And service layers is the highest level of the base software, which also applies for its relevance for the application software, while access to I/O signals covered by the issue abstraction layers, the service layers, and all those things. NVRAM managers and all, it will be there in the service layer, but you no need to worry about all those things. Once you are getting into the project, definitely you will understand it. The RT dependency he is explaining here. I think all these things we have seen it at the high level. Okay. So what this guy is telling here is like for application layer or runtime environment or base software or all this is the software, right? So for this they will be providing some standard libraries actually. Autosar libraries we call it as. So basically in our case we will be having what is this? We stdio.h, right? Standard input output.h, and for strings we are having some other header file, right? In the similar way, for calculating the mathematical calculations and all, we have the tan, cos, angle calculations, right? Sine angles and all those things. For this also we have the standard functions. All those things will be provided by the Autosar libraries is what they are saying it. Okay. Mathematical calculations and all those things. So now he was telling at the high level, like microcontroller high level right now, he is dividing that microcontroller microcontroller abstraction layer into the submodules again, like we saw it, right? I/O drivers, wireless communication drivers, crypto drivers, memory drivers, microcontroller drivers, and all those things. So what and all components will be coming is what he is explaining here. Like when we were discussing about this diagram, right? See, this part only, this what is this color here? The down one microcontroller abstraction layer one is explaining only the part actually. So here if you see we are having the can driver thing. Guys, are you able to understand it? So when we spoke about the microcontroller, we saw DIO pins, internal peripheral devices, and all those things, right? Internal peripherals in the sense digital input output pins, ADC pins, and PWM pins like a pulse width modulation. This what is this OCU, CCU? I'm not sure. Okay. All these things will be there. So that port connections he will be doing are the IO drivers. So this IO drivers he will be telling that which port is meant for which one. So then that communication will be happening only with that port. In case of CAN driver, you can see the CAN, it will be having CAN drivers will be there in the microcontrollers. So that CAN drivers, what it has to do is what will be decided by the CAN driver in the software. So that is how he is explaining for the other things. SPI, LIN, Ethernet, FlexRay, and all those things. Okay. Next in the eCal, you can see. So communication abstraction. So if any of the SPI is going to interact, okay, if you are trying to send some communication data on the SPI, then how exactly it is going to interact is what he is telling. Complex device drivers. So if any of the thing which you are not going to fall under this entire Autosar architecture, which is a BSW service layer eCal or MCal, then we will keep that into the complex device drivers. We are not going to bypass the RTE if application is trying to interact directly with the microcontroller. We are not going to bypass RTE. It will be going via the CDD, complex device driver. Okay, this is a hardware abstraction he has given it. Now you can see like the communication hardware abstraction, how it will be like CAN interface will be there. Then directly the CAN interface can interact directly with the CAN driver. Then the CAN driver is going to interact with the CAN peripheral which is there in the microcontroller. If you want to have the CAN transceiver, external CAN transceiver, then it will be part of the CAN IF itself. Then a CAN transceiver driver will be there. So CAN interface will be, CAN interface will directly interact with the CAN transceiver. Then CAN transceiver will interact with the diode drivers. Then with the CAN, it will go ahead. Then this is a memory hardware abstraction. You can see EEPROM abstraction or the flash EEPROM. If you have the external flash drivers, then flash EEPROM emulation will interact with the external flash drivers and all those things. Guys, this terms is very difficult for all of you to understand as of now, but definitely if you are getting into the project or if you are reading this document, definitely you will understand it. For me, all these guys are the familiar, so I will be just going through that. Crypto also has given like that. So I wanted to show you at the intercom. So here you can see like communication services, communication hardware abstraction, communication drivers. So these three things will be going to interact. That is the entire com stack. He is explaining here. You can see the content communication stack extension. Let me show you not the TTCAN. J1939 also I don't want. Lin also I don't want. Lecture also I don't want. For each communication protocol, he has given an entire stack actually. Hey, the first one only I think the TTCAT. Communication stack CAN. So here you can see like if the communication as we saw already from application, if it will come to the COM, Autosar COM, then from Autosar COM the PDR will take that input. PDR may go to the CAN transfer protocol or may not go to it. If it is more than 8 bytes of data, then it will go to the CAN transfer protocol, transport protocol. So if not, then it will go to the PDR directly to the CAN interface. So directly it can interact whatever it is coming from the upper layer, which is from the service layer. It should come to the CAN interface only. CAN interface, it may directly connect with the CAN driver also, or if not, then it will go to the CAN transceiver driver, then it will come to the CAN drivers. Getting it? So this is how the entire CAN communication protocol will have it. So you might be getting doubt what is the need of CAN NM, CAN SM and all those things. So state missions, like she might have told you like bus of operations and all those things, right? So that to handle that bus of operations, we will be having the state managers and network management. whether this particular issue, this whatever we are talking about only for one particular issue, right? Whether this particular issue should go and do it as operations as usual, or this is going to disconnect from the communication is what will be decided by the state managers. Getting it? So yeah, this is what I wanted to give at the base introduction for this Autosar. So definitely tomorrow what we are going to see is like this entire communication, how it is going to work out and all those things we will be seeing it. I will, if time permits, I will configure one of the CAN messages. Then I will show like how exactly the flow will be happening. Guys, if apart from this also, if you are having any of the doubts in the CAN communication, how we will be doing that in the software and all those things, even though Hamza is already explained, if you guys are having any doubts, still come back to me. If I know the things, I will clarify all of you. Any doubts? If no other doubts, I think for today I'm done. Tomorrow we will see at the tools level. Tomorrow also mostly we will be having the class at the same time. If this part Autosar is done, then I will be explaining the project once. Then the tools, entire tools, we will be seeing at a high level. Most of the tools you might have seen it already, but still I wanted to give you the overview what and all tools will be there and all those things. Any doubts in the Autosar? If no other doubts, thanks a lot for joining. Have a nice day ahead. Bye bye.
Thank you.